Today we're doing factoring quadratic expressions. Okay. Now this is a trinomial. We have a coefficient a, b, and a constant number c. We're specifically going to work today when a is equal to 1. Okay. The next day we'll start working when a is a different number. But today we're working with when a, the coefficient a, is equal to the number 1. Okay. Now, in order to solve this, I'm going to just move that. Working with a is 1. You guys will find the factors of a. So you're going to find some number and some number. And then you're going to find the factors of c. So who knows how many pairs of factors they are. We're going to put them in columns. And then what we're going to do is we're going to multiply our factors of our a by one set of factors of c. We're going to multiply them. Whatever the products are, we're going to add together, and they need to equal b. Now, it's very confusing because I haven't put any numbers there. Okay? So we're going to actually use an example. We're going to do example 1. So example 1 is x squared plus 6x plus 5. So the first thing I'm going to do is I'm going to write our theoretical model. Okay, our quadratic expression, we know we have an a b, and a c. So, in this expression, what number is a? 1. Good. Technically, it's a 1. What number is b? And c? 5. Perfect. So, what I'm going to do first is I'm going to find the factors of 1. What are the factors of 1? 1 and 1. So, 1 and 1. Okay? Another way we can describe it is what are the factors of our first term? What are the factors of 1x squared? Yeah, 1x and 1x. Okay? So our first terms, our options for 1x squared are 1x times 1x. Okay? Now our next options, the next set of factors, we need to find the factors of 5. What are our factors of 5? 1 and 5. Pretty straightforward. I'm going to put them together in columns. I'm going to set this up on the side. They need to equal two products that add up to, what is our b? 6. So we put the number 6 down here. So I've set this up. This is our formatting for this. Now, because there's only one set of column for our first factors and one for a second, these are clearly going to be the numbers that work. And you'll see why. What is 1x times 1? Or in other words, 1 times 1? 1. Okay? What is 1 times 5? 5. When I add 5 and 1 together, do I get 6? Perfect. So, here's what's important. I know I multiplied these by each other. Now, in factored form, we have two brackets. And we have our first terms, which are our factors of our a. And we have our second terms, which are our factors of c. So the factors we used were 1x and 1x, or x and x. So I'm going to put x in one bracket, x in the other. Those are both our first terms. And for our second terms, we use the factors positive 1 and positive 5. So I put positive 1 in a bracket and positive 5 in a bracket. Okay, so this was our standard form of the quadratic expression. We went through our factoring here, and we got to our factored form. This is what we're trying to do, set up a factored form. Okay, here's another example. So we're going to write our theoretical model quickly on top again. We have our a, A, B, and C. This will be example 2. Okay? Now in this one we know A is 1, B is 7, C is 12. We're going to find the factors of 1. What are the factors of 1? So we have our 1 and 1. What are our factors of 12? 1 and 12. What else? 3 and 4. Anything else? 2 and 6. A lot of factors there. We're going to set them up in columns. Okay. We know they're going to need to equal. The products are going to need to equal what number? What's our B? 7. 7's our B. We know the products need to equal that. So we're going to do trial and error. And we know we're going to be putting them into this form, factored form. So, our first set, what is 1 times 1 and 1 times 12? Are you serious? 1 and 12? Are there any combinations of 1 and 12 that equal 7? No. Okay? And we're going to go across. 1 times 1, 1 times 12. We still get 1 and 12. Does that work? No. So we know that this column, these set of factors, aren't going to work for us. Let's try the next pair. 1 times 3 and 1 times 4. What do we get? 3 and 4. Any combination of 3 and 4 work? Yes. Okay, so we use 1 times 3 and 1 times 4. We got the numbers 3 and 4. So my first terms are going to be 1x and 1x. And my second terms are going to be positive 3 and positive 4. This is now the factored form of our standard. So remember, this was our standard form. This was our factored form. We factored it. Still, here's another way we could have solved this. Now, this shortcut works only when A is 1. So that's why I want to warn you, tomorrow's lesson, this shortcut won't work. Let's look at our x squared plus 7x plus 12. Okay? Same numbers. We got our A, our B, and our C. C, B, and we know A is 1. Okay? Now, here's the shortcut. What I'm looking for, when I go into my factored form, we have our 2 brackets. Because A is 1, in this instance, we always know our first terms in both brackets are going to be what? X and X. Because there's no other factors of 1. They're just 1 and 1. So 1x and 1x, or x and x, are always going to be our first terms. Our second terms are going to be this. 2 numbers. We're looking for 2 numbers that multiply to C. And what's C in this instance? 12. Okay, so we need 2 numbers that multiply to C. And those same 2 numbers need to add to our B term. So I'm just going to move this down a little, show you what it looks like. So what that means, our C is 12, so we need 2 numbers that multiply to 12. And the same 2 numbers need to add to 7. Those will be our second terms. So we already figured it out in the other one. What 2 numbers multiply to 12 and add to 7? That's right. So 3 times 4 equals 12, and 3 plus 4 equals 7, both positive. So my second terms are positive 3 and positive. Okay. We need to factor these terms. We're going to do the first method of factoring first. We know what our B is, and our C, and technically our A. I'm going to find the factors of A. What are the factors of A? 1 and 1, easy. Factors of 21. 1 and 21, and 3 and 7. We have 2 sets of factors for our C. We know the products need to add up to our B term. which is negative 4. We know our factor form is going to look like this. What are our first terms going to be? We already know it's going to be 1x and 1x because our only factors of our only set of columns is 1 and 1. Now, 1 times 1, 1 times 21. That gives us 1 and 21. Any combination work? No. What about if I do 1 times 3 and 1 times 7? I get 3 and 7. Is there any combination of that works? I have to add them, okay? What term, how can I change one of these? I can change the integer from positive to negative. So, which integer do I change negative so that this works? 7. If I make 7 negative, 3 plus negative 7 equals negative 4. So, I multiplied 1 times positive 3 and 1 times, this is where I put it in after, negative 7. So, my second terms are going to be positive 3 and negative 7. Those are the two that work. And the other way to have done this, same idea, same question, x squared minus 4x minus 21. We need, remember, two numbers that multiply to negative 21, and they need to add to negative 4. So if I had done, does positive 21 times 1 equal negative 21? No, one of those have to be negative. We know that combination doesn't work. And we also, if we did negative 21 and positive 1, those combinations don't work. We know that they work for this, but didn't work for this. Okay? Our other options were 3 and 7. Now, positive 3 times positive 7 isn't negative 21. If I had negative 3 and 7, that would give us positive 4. It didn't work and worked. So our options are negative 7 times positive 3. Negative 7 plus positive 3 equals negative 4. So I know those are the pairing that work. This is a trial and error method, just like the other, I guess. So when we put it in our factored form, we always have x to start, and we have negative 7 and positive 3. If you guys notice, it didn't matter which order I put them in for now, okay? I put the positive 3 in the first bracket, negative 7 in the other, or the other way around. It doesn't matter today. When a is a number other than 1, what brackets they go in does matter, okay?